Greetings. In the last video, I talked a little bit about Tripath Technologies audio chips. Well, today I wanted to talk about one particular chipset, the TK2050/2051 chipset. And that chipset was comprised of two items, the TC2000 or 2001 audio controller, and the power stage was a TP250 or 251. There's slight differences between those two power stages and also the controller stages. But this is a 50 watt per channel chipset that was used in a number of devices, and I'm sure they used it in multimedia devices, televisions, and other things. But this happens to be in that little Lepy second amplifier that I bought, the LP-2051. And it was damaged when I got it. But after a few minor modifications, it really surprised me more than the little LP-2020 amplifier that I have. And it's really too bad that Tripath had to close its doors in 2007. But from what I can ascertain, the competition was starting to close in and heat up, especially ST Microelectronics and Texas Instruments. They caught up and were starting to make these audio chips of their own. That's Class D. You know, Tripath was a small company, and it really couldn't compete against the larger manufacturers. And plus, as far as I can tell, information I found, that Tripath, they must have been dumping a lot of products to their distributors, which in doing so overvalued their stock because they got in a little trouble over that. At one point, one of the main distributors returned $1.5 million worth of devices and components, and it seems that sometime after that is when they went bankrupt. So getting back to the this little LP-2051, when I received it, the speaker terminals on the back were broken, and this is what they look like. You can see all the spring tabs are gone, the springs are gone. I mean, it should have looked like the back of this little 2020 amplifier, where you can actually attach the wires. But after some internal modifications, and it looks like this now. This is what it looks like now. What I did, I added speaker posts, and I added switchcraft RCA jacks for the input. I removed the 1/8" input jack, and I'll tell you how I did that, and what I did I'll show you. This guy's a little bit bigger than the 2020. It's a little bit bigger inside, but also I modified it a little bit. I put in some new electrolytic capacitors, and as I was replacing them and testing as I go, I figured out the ones that really made a bigger difference in the sound. And I put in some Panasonics and some Nichicon, is that how you pronounce it? The Nichicon caps. I can't pronounce the Japanese names too well, but I put in a couple audio quality caps, and the rest, the other normal Panasonic regular caps. And I think it made a difference because I'm awful surprised. This one even sounds better than the 2020, and this thing actually rivals some of my tube amplifiers. Now, I've always been a low power guy. I don't have anything over 50 watts per channel in my tube amplifiers. My push-pull KT77 is 50 watts a channel, and my single-ended parallel 6L6 is about 19 watts per channel. And some of the others, I have a 5 watt KT88 single-ended, and I have a few others. but I never had a need for massive power, and they work fine driving my BMW 602 S2s that actually I had put in the crossover upgrade kit from GR Research. But I don't want to call myself an audiophile. I'm just a regular guy. So I call it sound for a regular guy because I'm not, getting into all these things. I noticed I saw on the internet news and a couple YouTube videos where they auctioned off that fellow that built his custom $1 million sound system, his audio system. They auctioned all the components off because he had passed away. But let's take a look at what I did with this little amplifier. And actually, I was surprised at the square wave on a scope at full output, and it was pretty good for a square wave. And I'm telling you, it really sounds good. It rivals my low power tube amplifiers, and to my ears anyway. So, and I've had a couple other people listen to my tube amps, and they were quite impressed. And I think this thing stands its ground with this little thing with my tube amplifiers. But I'll show you a few things that I did here coming up. So what I did was use the original back thin metal plate for a template. And I made another piece to sit behind it out of double-sided copper PC board, give it a little strength, and it was easy to work with. And I had to raise the binding post where the holes were so they didn't interfere with the components that were on the back of the board. And also I removed the 1/8" jack that was for the other audio input and removed that housing that held the original RCA jacks and mounted some new Switchcraft RCA jacks. Here's what it looks like from the inside and how I attached everything. One of the problems was trying to figure out how to design this so that you could actually take it apart again without unsoldering anything. So what I did was got those binding posts. If you see, they have little set screws in them that you can hold your wiring, and so it's really simple to disconnect them by just loosening the set screws. And the biggest wire I could fit in that PC board was number 18. So tinning the end of it real good with solder and tightening down those set screws, they held in there pretty good. And the RCA jacks mount from the rear with the nuts on the front of it on the outside. So in taking apart, there's no unsoldering there. You just have to loosen those nuts and pull the RCA jacks out. You can see the piece of PC board sitting there in between as a wafer in the back. And actually the original screws were long enough to put it back together. So I think that was a big improvement over the original RCA input jacks, and also the original speaker binding posts with some nice heavy brass ones. Before we look at the circuit board, I wanted to mention the power supply that originally came with this was a 60-watt power supply. And there were issues when I was doing testing at full volume that it actually would draw the power supply down and the relays would kick out on the amplifier. So I had a 90-watt power supply, the same voltage, 19 volts, which seems to really work well. Here's the circuit board. Let's look at the two Tripath chips first. The TC2001 controller was actually exactly the same as the
TC2000, except the 2001 was a lead-free package. And the TP2051 50 watt per channel output chip actually was almost identical to the 2050. I don't know why Tripath did this with the numbering, but the 2050 actually replaced the 2051 because the 2050 was a thermally enhanced package which provided more effective heat removal, and you can see the built-in heatsink on the top of it. So it's possible that this unit didn't even need a heat sink when it was used in devices like flat screen TVs and such, where a lot of these were used. But I don't think Lepy made too many of these little 2051 amplifiers because you really can't find too much information about it on the internet. And I only found one fella that did some testing. I think Wolf Tech has a video out on YouTube. So actually there are about a handful available over AliExpress, I think, for around $70. So I'm not sure what the deal was there, why they changed the naming as they did on the numbers of the chips. So it is what it is, I guess. In looking at the capacitors that I replaced, the large power capacitor up at the top on the circuit board here, that is a 5600 microfarad. I increased that. I put a bigger one in that was in there. And all the capacitors on here are Panasonic and Nichicon. Now, some of the important ones to change are the two green ones, which are the input. And those are Panasonic audio grade. And the one behind the heatsink for the output chip between those inductors. Now, that one actually, there's a different one in there now. That's a Nichicon, but I found I had a audio grade, one of the gold, I think it's called, Nichicons that I put in there. And I'll talk about those capacitors and why that one and the two input and also the one with the blue tag on it is important to use a really good quality. Other than that, the other ones were standard Panasonic capacitors. I traced out some of the circuitry on the board, and it is very similar to the technical documentation from Tripath for this chipset. So here is some of the connections for the TC2001-2000 controller, and you can see in green where the two input capacitors are, and also the blue capacitor, which that made an important difference when I put a better quality capacitor in there. As I was replacing these, I would replace them and then I would listen for a while just to see. So that is a spot where you'd want to put a good quality capacitor in on that position where the connection is, where I have it circled in blue. Now, some guys say, well, let's increase the voltage. We can get more power out of these amps. I know some people have done that with the 2020 chips, but taking something that has already been designed like this, I don't feel that's a good idea, because if you look at the components I have circled in orange here, now those components are chosen according to the power supply voltage. And if you read the technical documentation farther down in it, there are some formulas that you need to consider if you're changing the voltage on the input of the, actually has to do with the output chip, but it needs to be balanced right for the signal coming out of this controller chip. So I really wouldn't want to mess with the voltages on this one and go any higher than a recommended 19-volt power supply, because that's what this particular board was designed to use. Now the capacitor that I have labeled in red on the PC board and on this schematic from Tripath, it's an important one to replace with a really good quality capacitor, because that is actually a high frequency bypass capacitor. Now they call for a 560 microfarad capacitor, but the issue was on this board, you can only fit something that is 10 millimeters in size between those two inductors. So I had to settle for a 470 microfarad. Of course, that's what was in there in the first place. So that worked out well. I also wanted to mention about the output inductors. Now the output inductor and output capacitor, both of these together form a second order filter. And this filter demodulates the switching waveform into an audio signal. Now I've read in the forums where a lot of guys have thought to replace these, thinking they can do better. But these output inductors in the Tripath amps, it's a critical thing, making the right choice. You really need the right instrumentation and understand what you really do and the right testing. According to the documentation, these output inductors are critical, and also the core material and the geometry of how they're wound affects the distortion levels in the amps. Now, I remembered back, there was a website and a company that manufactured parts, T-amps and such. I really can't pronounce it, but AUTOCOSTUIRE.com. And I noticed they offered output inductors for the 2020 T-amps, the replacements, which were supposed to be a little better. So I understand that someone had figured out how to do that. And they even had the white ones there, they were wound with Litz wire. Now, believe it or not, I managed to contact Antonella about this. And of course, he mentioned the website was out of business, but I was looking to see where they sourced them. But they actually didn't source them. They wound these and did these in-house. So I'm really going to leave that part of this amplifier alone and not mess around with it, because I don't have the time, the instrumentation to actually see if there's some improvements could be made there. There are two adjustments on this board. I have them circled in yellow in the picture there. These are to adjust the DC offset at the output. Now you want to get that as low as you can. After I replaced all the capacitors and had it on the bench, the DC offset was already pretty low. It was only 26 millivolts. And I got it down, the adjustments down to each channel down to 6 millivolts. So that was pretty good. So let's look at a couple waveforms that I took on the output of this thing with the scope. This is a 1000 hertz signal taken at the output at full volume with 1.5 volts in on the input of the amplifier, and you can see it's at full 19 volt on the output. And it's not too bad. There's just a tiny little bit of ringing at the top, but I'm not sure whether that's an artifact because of the output filter. I haven't had too much experience with the Class D, so that may not be a problem at all, but it sounds fine. Here's a 10,000 hertz square wave signal, taking it full output with 1.5 volt in. And as you can see, we've got the full power supply, 19 volts on the output. Now, when I take these, I have 8 ohm speaker lobes that I connect up to the output of the amplifier, but it looks pretty good. So there you have it, the Lepy LP-2051 with a Tripath chipset in it. And if you have any questions or comments, shoot an email, make a comment. And if I can help you, I can help you. If I can steer you in the right direction, I'll do that too. So other than that, have a good day. God bless.